So we're on the bottom of page 8 down here, but we do need to look at the top of page 8 to be able to do that part of the page. So for the past couple problems, we've been looking at two-way tables with numbers in them. And we actually can do two-way tables with probabilities, and that gives us a little more direct information, and it also lets us work towards this formula we're going to use on the next page. So when we fill out those numbers, first off, the total probability in both of my totals columns is always the number 1. The rest of the probabilities we're going to find by taking a specific cell and dividing by the total as we would if we were finding probability like we did at the top of the page. So if I did that, I'm going to write out 113 divided by 938 is going to go in this cell, and to the nearest hundredth, that number is going to come out to 0.12. I'm going to show one more. So this cell, we would divide 72 by 938, and that would come out to 0.0. So if I continue doing that with every single cell, 185 divided by 938 is 0.20, and continuing on, I get 0.30, 0.50, 0.80, 0.58, and 0.8. And I should see those same qualities where the rows add up, the columns add up. There is a chance with the rounding that I'll be off by like 0.01 in some spot, which actually that's not in the homework for this, but the general idea of everything kind of adding up works. So we're going to look at the next page at this table already filled out. So on page 9, these are the same exact numbers I just found. Now, there's generalizations that we can get from this. So I'm going to fill in this we called S and not S. This we called A and not A. So in general, it's a little tricky because I did put my A up here. I have two general events, event A and event B. The probabilities that we find can be represented in this table. So over here at totals, if I have probability in here, this is the probability of B. So the probability of whatever that event is, in this case, if student indicates he or she has asthma, is 20%, and I can look that up. So in the same way, this is the probability of not B, this is the probability of not A, and this is the probability of A. When I come into these inner four squares, then I'm finding the probability of an intersection, right? So this is the probability of both A and B. This is the probability of not A and B, and this is the probability of A and not B, and the probability of not A and not B. So all of my intersections are in there, okay? Now, the thing I don't see in there is I don't see any unions. But from this, I can get the formula that we use to find the probability of the union of two events. So if I was finding the probability of A union B, when we were doing this without thinking about a formula, we added up the probability of A, so the total right here, the probability of B, so the total right here. And we did this with numbers, not probabilities, but it works the same way because the table has that symmetry. The problem was sometimes we got a number bigger than our total, right? Or in this case, bigger than 1. And even if I didn't, I counted this P of A and B twice, so my answer is not accurate. So what I need to do is subtract that. And this is the addition rule for probability. Anytime I want to find the probability of the union of two events, I need to add the two probabilities together and then subtract their intersection. So the way this would look, I'm given these probabilities. I don't even have a table. I could fill it out, but the idea of the formula is it's a quicker way when I want to find the union of the two events. If I'm given the probability of the first event, I can add it to the probability of the second event, and then I can subtract that intersection that we counted twice. So if I add these up, and you can do this on a calculator, I get 0.42 plus 0.35 minus 0.23 is 0.54. So that is the probability of the one event or the other. The next one is using this formula, but we're going to have to do a little algebra. So this time, I'm given the union, so I'm going to put that over here. I know P of A, so I put that in. I'm trying to find P of B, so it's as if it's a variable or is a variable in the equation, and then I'm subtracting off P of A and B. So I get 0.68 equals, if I subtract these two, 0.14, right? And then plus P of B, and then I can just subtract the 0.14 for both sides. And I do get that P of B, in this case, equals 0.54. Now, that is just by chance that this comes out exactly the same as the other one. That doesn't usually work. It's probably something I'll change for next year.